Good morning, everyone. Today in this lecture, we'll see what a rectifier is and what are the basic types of rectifiers. So coming to a rectifier is a simple electrical device that is used to convert your alternating current into a direct current by the usage of PN junction diode. So the main question or an important question will be like how this alternating current is getting converted into a direct current and how does this PN junction diode help in that. So as we all know, our PN junction diode will conduct only when it is connected in the forward bias and it does not conduct in reverse bias. So what this forward bias and reverse bias means? So when the p-type material of the diode is connected to the positive supply and the n-type material is connected to the negative terminal of the supply, we call that to be forward bias. And when the p-type is connected to the negative terminal of the supply and the n-type is connected to the positive terminal of the supply, we call that to be reversed bias. So what happens when this diode is being connected in forward bias? When a diode is being connected in forward bias, there are, when you consider p-type, there will be few minority carriers which are electrons, and in the n-type also there will be few minority carriers which are the holes. So due to this supply, that is the positive terminal with the p-type and the negative terminal with the n-type, there will be force of repulsion, due to which the electrons and holes gets repelled towards this junction and a depletion layer is created. The depletion layer width is very small when the diode is connected in forward bias, due to which the current passes from one terminal to the other. But when you consider a reverse bias condition, it is completely opposite, where the electrons and holes gets attracted towards the junction diode and the depletion layer width is getting increased, due to which the charge carriers are not able to move from one terminal to the other. So we do not have any current passing that is occurring from my cathode to anode. So that is the reason why we say that the PN junction diode conducts only when it is connected in forward bias and it does not conduct in reverse bias. So this is how we say that by the use of this PN junction, one or more PN junction in a circuit, my alternating current is converted into a direct current. So how does this get converted? Generally, when we say a DC signal, it is actually a straight line. But then how is it possible to get a straight line by giving an alternating current? When you use a PN junction diode, we actually do not get a straight line as a DC signal, but then we get a pulsating DC. Okay, like whenever I have a positive signal, that is a positive cycle of input signal, I will be getting an output. Whenever I give a signal which is there in the negative quadrant of my negative quadrant of the input signal, I will not be getting any output. So at the end, when we see whenever I have a positive input, I'll get an output. For the negative cycle of the input, I'll not be getting any output. So it will be on off for the positive and negative cycles respectively. So there are few types of rectifiers, common types of rectifiers like half wave rectifier, full wave rectifier and the bridge rectifier, which is being commonly used to convert my AC signal into DC signal. So first we will see what this half wave rectifier is. So as you can see in this diagram, a half wave rectifier consists of a transformer, a diode and a load resistor. So this transformer basically is a step down transformer where the given input voltage is converted into a lesser voltage than the input voltage. As we all know, this rectifier converts my AC to DC. So I am giving an AC signal as input, where I have positive supply as well as the negative, where I have the positive portion of my input and the negative portion of my input. So when I am giving this signal as input to this diode, for if you see, my positive half is connected to the positive part of my diode, which is the anode. So this signal, when it passes into this diode, this plus and the positive part of the diode, so it means they are there in the forward biased condition. So this positive input signal will be reflected the same at the output terminal. But then coming back to this negative cycle of my input signal, this negative value and the positive part of my diode acts as reverse. When they are connected, it acts as reverse bias. So what happens, as we have already told, a diode does not conduct when it is connected in reverse bias. So under whenever I have a negative signal which is given as input to my half wave rectifier, I will not be getting the output. Coming to the next positive half cycle, it is given as input. My diode will be in forward biased and it conducts. So I will be getting the output. Coming back to the next negative cycle, the diode will be in reverse bias, so I will not be getting output. So for every positive half cycle, there will be output. For every negative half cycle of the input, there will not be any output. So what will be the output signal? It will be of 1 0 1 0. Okay. So now we'll see how this circuit actually acts when it is forward bias and reverse bias. What happens to the diode? Why I do not have any current flow in the device whenever a negative cycle is being given as input to this diode. Okay. So in this diagram, for the first cycle, when you see this my positive cycle is given as input. As you all know, diode acts as a switch. So whenever I give an input signal which is in the positive cycle, the diode acts like forward bias. So it means that the circuit is closed and it acts as a closed switch. So whatever signal that I am giving as input, it will reach my load resistor and I will be getting the output. Now coming on to the other side, when I give a negative signal as the input, my diode becomes reverse bias. So whenever a diode is working in reverse bias, the diode gets opened. So the circuit will become an open circuit and the signal that is being given as input does not reach my load resistor. So for any circuit which is open, the current does not pass from one terminal to the other. So when the circuit becomes open, I will not be getting any output for the negative input, negative cycle of the input that I have given. So for the positive cycle, the circuit is closed and I will be getting the output. And the same when it comes to the negative cycle, the circuit becomes open, that is the diode is in reverse bias, so I will not be getting any output. Now coming on to the comparison chart of my input signal and the output signal, you can very well infer from the input signal. My input signal has both positive cycle and the negative cycle. But when you see in the output side, you can see that the output is obtained only for every positive half cycle that is being given as input. So from this output waveform, you can see that a portion of my input signal is being wasted. Only one part of my input signal which is there in the positive part is being used, but then this waveform which is there in the negative cycle is being completely eliminated. So there is much waste of power in my half wave rectifier. So in order to overcome this, there is another design which is called as full wave rectifier. So a full wave rectifier is actually designed to overcome the main disadvantage in this half wave rectifier, which is the wastage of power. Okay. So this full wave rectifier we will be discussing in the upcoming class. So today what are all we have seen? We have seen what a rectifier is. What is a half wave rectifier? A rectifier is a device which converts my AC to DC by the use of one PN junction diode or more than one PN junction diode. So types of rectifiers are half wave rectifier, full wave rectifier and the bridge rectifier. When it comes to a half wave rectifier, we are having a transformer. Along with the transformer, I have one diode and the load resistor. So the circuit becomes alternatively opened and closed based on the input signal that I am giving. Positive cycle, my circuit is closed, so the diode conducts which is in forward bias and I'll be getting the output. When it is when I'm giving my negative signal as input, the circuit becomes open, which is the diode, which means the diode is in reverse bias, so I'll not be getting any output. On a comparison of my input and the output, I'll be getting the output only whenever I have a positive signal which is being given as input. For the negative input, I am not getting any output. So portion of my input signal is being wasted. So this is an introduction and a description about the half wave rectifier. Thank you.